This video is going to cover extreme value theorem. The extreme value theorem specifically states that if f is a continuous function on an interval that is closed from a to b, then f will attain an absolute max and it will attain an absolute minimum. So given this cubic function right here, on the values from -2 to 3, that means that we have all x values from -2 to 3. By the extreme value theorem, given that this is a cubic function is a polynomial, and a polynomial is continuous on all x values, that means that this should apply. So if this is the case, the step is to first identify again where it can have maximum or minimums. Well, to do that, I'm going to go ahead and take the derivative of this function, providing me with 3x squared minus 3, and then plus a 0. So that's the derivative of that function. Now, to find the locations where it could have a local max or a local min is by setting this function equal to 0, because the derivative is where the slope is 0, gives me horizontal tangent lines. And again, horizontal tangent lines will occur at locations such as, again, this one here, or it will occur at locations such as this one down here. And again, notice both of those is a local max and a local min. So with that being done, I'm going to go ahead and solve this equation. So 3x squared minus 3 equals to 0 gives me, factoring out of 3, x squared minus 1 equals to 0. Factoring this gives me x minus 1 and x plus 1. Now, in this example, each factor has to be equal to 0. Well, 3 can't equal to 0. That doesn't make any sense at all, so that is not considered a value we're going to look at. However, x minus 1 equals to 0 gives me x equals 1, and x equals to -1 is provided by the x plus 1 equals to 0. So those two locations are what we call critical points. So I have two critical points that are potential values, and then I also have -2 as an endpoint and 3 as an endpoint. Now, if you look at this cubic function here, you can identify that there are possible locations where it's going to have a local max or a local min. But the problem is that if I look at any cubic function, if I draw a couple of different cubic functions up here, you'll notice it does not have any absolute max or min. There is no point on this curve that is going to be larger than all the others, because this is going to go off to infinity. Same with this one going down to -infinity. So I will not have an absolute minimum on this curve. However, because of the fact that I'm limiting myself to -2 to 3, and that these 2 points right here are both in that range, that means that I could have a maximum at -2. I could have a maximum at -1. I could have a maximum at 1, or I could have a maximum at 3. Providing all these values, I can identify which one of these 4 is my absolute max and which one of these 4 is my absolute min. So if I plug in -2, the original function, again, I'm plugging this in, -2, the end point, into the original function. So at -2 for f of x, I'm going to end up with a -8, that's 2 cubed, that's negative, and then minus, so plus 6, because again, that's -2 times -3, and then plus 1. This provides me with a -1. Now, I don't know if this is going to be my max or my min right off the bat. I'm going to have to find all of these other values, but I do know that based on this cubic function, it should look something that looks like this. Again, it should look something that looks like this, and you'll notice we have a high point, a low point, and then we're going to cut it off somewhere here and cut it off somewhere here. So based on that, ignoring all the values above and below, I should be able to identify either one of these 2 points as my lowest value or one of these 2 points as my highest value. So let's plug in -1 next, providing with -1 and then plus 3 and then plus 1, giving me a value of 3. So again, so far it appears as though -1 x value is going to provide us a absolute maximum at 3, and a -2 x value is going to provide us a local or an absolute minimum at -1. Now this isn't guaranteed, so what I'm going to have to do is I'm going to have to check these other 2 points as well. So when I do that, I get 1 minus 3 plus 1, which is going to provide me with a -1 there as well. And when I plug in 3, I'm going to end up with, let me double check that, yeah. When I plug in 3, I'm going to have 927 minus 9 plus 1. Provides me with 18 plus 1, which is 19. So it looks like this right here is going to be our absolute maximum value. And now I'm going to be very specific about this. This is the absolute maximum value. Where does that maximum occur? It occurs at x equals 3. This one right here and this one right here both appear to be the absolute minimums. They are both absolute minimums because they are together the lowest value on the curve. Again, that's the lowest value. And where do those occur? It occurs at -2, at x equals -2, and it also occurs at x equals 1. In that case, we now can guarantee, even though a cubic function continues on forever in both directions, if I limit it based on a closed interval, that does provide me with a guaranteed absolute min and a guaranteed absolute max.